This is the recording of review notes number 1. Now these recordings will be a little bit faster, actually quite a bit faster than in-class videos, because you have the ability to pause, rewind, and fast forward. So bear with the speed, but do remember you do have control over the tempo by fast forwarding and pausing and so on. Let's start with a variable. A letter that represents more than one value. Now what does that mean? Well, one example is if I gave you the example 3x equals 21. You can ignore the asterisk there or the star. 3x equals 21. What is x? Well, to solve for x, we would divide both sides by 3 and we would get an answer of x equals 7. In order for that equation to be true, we would have to plug in a 7 for x. Now in another example, if we have x plus 1 equals 5, if we solve that one by subtracting 1 from both sides, we would see that in order for that statement to be true, x would have to be 4. Now notice that the variables are the same, yet they have different values depending upon the equation that it's put in. So therefore a variable can represent more than one value. Expressions will be next, and that is that it contains variables, numbers, exponents, and operation symbols, but no equal sign. Now this is a very important piece of this statement. So let's look at some. 3x, again ignore the asterisks on the left side here. That is an expression, 3x. It means 3 times x. Or just 21. It does not have to have a variable with it to be an expression. It is a term. And x plus 1. So there it shows an operation symbol in between the two pieces. Those are all expressions, but notice that none of them have an equal sign. Like terms means terms with the same variable parts. Now if we look at an example here, we have to pay close attention to whether or not they have the same letters and exponents. So here we have 3x and x. Now they have the same variable. There's a 3 out front, but it means 3 x's, or 3 times x, and then just x. They are considered like terms. However, if I had 3x and then x squared, the power over the variable has a lot of power, no pun intended, and therefore these two are not the same variables. They are not like terms. The x is the same, but they are not considered like terms. So if the power had not been 2, had it been a 1, like the 3x has a power of 1, even though they do not write it, they would then be considered like terms. Here we have an example as a car is traveling at an average speed of 45 miles per hour. Write a variable expression for the distance traveled in h hours. A variable expression, remember, a variable expression means no equal sign. So all they're looking for is an expression. So let's take a look at something that we would naturally do. If we have 45 miles per hour as a average speed, and I wanted to see how far we got in 1 hour, I would take it times 1. And that should make sense. In 1 hour we should have gone 45 miles. However, if I traveled 2 hours, I would take it times 2. In which case we would get 90 miles. Now this would continue on, but if you notice there's a pattern here. If I want to know how far I traveled in h hours, not 1 or 2 specifically, I would take 45 times h. And that would tell me how many miles we went. So the abbreviated version of that answer would be 45h. You don't have to write this multiplication symbol. Now notice I did have equal signs here, but this is a calculation that I was doing to make sure I understood what the process was. Down here notice there are no equal signs. It's just the expression. Example 2. Write a variable expression for each phrase. Alright, so let's take these sentences and come up with a variable expression. Again, no equal signs, just expression. twice the length L plus twice the width W. Now twice is pretty important to see. It means 2. Twice something means taking something times 2. So I will say twice the length, and I'm going to use L in penmanship there, okay, cursive, and then I'm going to say plus, so there's that symbol, twice again the width W. Now notice I don't write equals, I just say plus, and that is the expression. B, the square of the number of items n times 4. The square of the number of items n times 4. So n times 4 can be written as this, or we would normally write the term or the number first, so this is the proper way to write it, 4n. The square of the number of items n times 4. So the square is a power, so we're going to take 4n and we're going to square it. Alright, I'm going to back up a second. I paused it there, you couldn't tell, but I paused it there to double check and make sure I was interpreting this right, and I wanted to make sure I did it right for you. I'm going to back up here and take these out. Now what I failed to interpret was, pardon me here, what I failed to interpret sorry about that, hang on, getting used to my computer again. Alright, I have to watch very closely the way they word this. Okay, so let's try that again. Alright, the square of the number of items n. So that is one piece. Okay, I did n times 4 first, and I had to read this more carefully. So the square of the number of items n. So I want to go n squared. Then I will take the next piece times 4. And as I said before, we would write the constant or the number first and then the variable second. So this is the appropriate way to write that. So again, that didn't quite sound right as I was saying it, so I'm glad I checked that. Alright, C. 1 less than 3 times x. 1 less than what? 3 times x. So 3x is one piece, and it says 1 less than that. Now, this is the one case where we actually do not do 1 and we think less than's minus. We do not do that, okay, because less than is a switcheroo. So we would actually go minus 1. So you're saying 1 less than. So if I said what's 1 less than 10, it's 9. So 1 less than 10 is like 10 minus 1. So it's kind of a switcheroo. We have to pay close attention to the wording for less than. Alright, let's simplify each expression. Alright, so we have, in this first one here, we have a k variable in each one. These are considered like terms. So there's 10 k's here and 7 k's there, so together we can put them together and write 17k. On the B, notice we have n and a plus 2n. Those are like terms. Now there's a 1 in front of n, so when I put them together I have a 1n plus a 2n to give us 3n. And 7 is still a minus 7. No like terms for that one. Next one we have 4a, a positive 4a, and a positive 5a. Together we have 9a. These two, negative 3 plus 5, are considered like terms. They don't have any variables, so therefore they're considered constants. Those two can go together. So negative 3, that's what minus 3 is. A negative 3 plus 5 is a positive 2. Our last example here is solving. Now we're going to solve this by undoing. So if I have v minus 14, I'm going to add 14 to both sides to undo the equation. So now we have v equals, because these canceled out, and negative 9 plus 14 is a 5. Alright, b, we have 8 minus negative 4a. Well, this is negative 4a times, or negative 4 times a. So to undo multiplication, we divide. We're going to divide by the negative 4. The negative goes with it. But you have to do it to both sides, as I did in the first example, or the first letter. Otherwise it's not considered appropriate, because we have a balanced equation. We have to maintain balance. So this would give us a on the right, and 8 divided by negative 4, which is a positive divided by negative is negative. 8 divided by 4 is 2. Now I could write a equals negative 2. That's fine. Both are considered the same. C, it's x divided by 16 equals 3. Now there's two ways to do this one. One is to say I'm dividing by 16, so I'm going to multiply both sides by 16. And that will give me x equals, because again, my division and multiplication cancel out, and I get 3 times 16. And that would be 48. There's one other way to do this one I'm going to show you, because lots of people are comfortable with cross products, and that's also going to be reviewed later. But I could write 3 over 1. And that means I would take x times 1, which would give us x, 3 times 16, which would give us 48 also. Same solution, just two different approaches. And this ends review number 1.